Hey everybody, so we're on lesson 4 and we are talking about slope-intercept form of a linear equation, and linear equations are written for linear relationships. So let's get started with our vocab here. All right, we have a linear relationship, a two-variable relationship that has a constant rate of change. So you're going to want to copy this down into your notes. You can highlight, you can circle, you can underline. Make sure that you make the notes work for you. Okay, so you know that, you know what a linear relationship is, and let's just nail down exactly what the different types of linear relationships are. So we have proportional relationships, which we've been working with a lot lately, right? We even wrote equations for them, we graphed them, we made tables for them. Okay, so we've been working with them a lot. We're going to switch gears and we're going to be working with non-proportional relationships. Okay, so let's compare and contrast those right now. Okay, proportional relationships, they have constant rate of change. We find that by finding the change in the y, or the rise, and the change in the x, or the run. Okay, well, that's the same. Okay, they're the same in that they both have constant rates of change. Why is that? Well, they're both linear relationships, and all linear relationships have a constant rate of change. That's what makes them straight lines on the graph. All right, now here's a difference. Okay, proportional relationships have a constant ratio where you can just take the y-coordinate and divide it by the x-coordinate, and all the points will equal the same number. And then this does not have a constant ratio of y over x. It does not. All right, so we have this constant rate of change, constant rate of change. Constant ratio, no constant ratio. Here we have the graph is a straight line and it goes through the origin. Okay, here we have the graph is a straight line but does not go through the origin. And we'll be talking about the fact that it doesn't go through the origin a little bit later. All right, and for a proportional relationship, you can write a general equation in the form of y equals mx. That's a little bit different than non-proportional. An equation can be written in the form y equals mx plus b, and this is our focus for today. Okay, that's special equation for non-proportional linear relationships. All right. Make sure you pause and get that copied. Okay, you might have to go back or take some time to write that down neatly. Okay, now we have slope-intercept form of a linear equation. All right, this is the key for today. We'll put a little star here. All right, so this is the format. The y and the x will remain variables, but we're going to plug in special numbers for the m and the b. And those special numbers are, m is going to be our slope, and we know how to find that in a lot of different situations. We know how to find it from a table. We know how to find it from a graph. All right. We know how to find it when given just 2 points from a linear relationship. Okay, and now we're going to be introducing this new thing, the y-intercept. Okay, and that number is going to go in for b. Well, what is a y-intercept? Y-intercept is the y-coordinate of the point where a line crosses the y-axis. This is a super tiny drawing, but you get the point that when this line crosses the y-axis, okay, this point here, if we look at the y-coordinate, the second coordinate, that is our y-intercept. Okay, so see, I wrote -2. You can barely even see that, but we'll review that now on this next page. Okay, all right, let's go and talk about finding the y-intercept, and this is where we'll stop today. Okay, fairly short lesson. Finding the y-intercept for lines. All right, so let's look at line 1 here. Okay, line 1, what is the y-intercept? Okay, well, if we go back to our definition, y-intercept is the y-coordinate of the point where the line crosses the y-axis. We know that this vertical line here is the y-axis. This is the x-axis. So where does this line cross the y-axis? We follow it, boom, right there. Okay, so the y-intercept of line 1. Now there is some, like in our book it says it's the y-coordinate of the point where it crosses the y-axis, but I like to write the whole point out. So we have the y-axis, we have the line, it crosses right there. What are the coordinates of that point right there? Well, we always start at the origin and we say we have to walk to get to the elevator. So we walk 0, we go up 1. So that's 0, 1. And in the book, if they asked for it, all you would have to put is the 1. Okay? That is the y-intercept for this line. All right, let's look at line 2. Okay, what is the y-intercept? All right, well, let's see. We go like this, follow it until it crosses that y-axis. Put a dot there, and let's talk about that point. So we walk, we don't have to walk anywhere from the origin, we just go straight up. 1, 2, 3, 4. That's 0, 4. All right, and then in our book, when they ask you, you're just gonna put the 4. Okay, last one, let's see if you can do it on your own. Okay, what is the y-intercept for line 3? We follow that line, we see where it crosses, and that's right there. That's start at the origin, 0 over, 1, 2 down. So that's 0, -2. All right, that's where we're gonna stop today. You might notice something interesting. The x-coordinate of the y-intercept is always what? What'd you notice there? The x-coordinate of the y-intercept is always 0. And that we'll be using later in later lessons to as a clue to help us solve different parts of some problems. All right, good stuff, pretty short. Hope your Friday's awesome and your weekend's great.